DynamoDB supports using custom types in your documents. Now, based on your programming language, if there is no direct mapping from these custom types to the DynamoDB types, then you will need to specify that yourself. In this video, let's learn how to use custom types and to specify converters so that you can save these custom types to your DynamoDB documents. We will be using .NET for example, but the concepts apply to other programming languages as well. Hello everyone, welcome back to this YouTube channel. My name is Rahul and I make videos around .NET, Cloud and DevOps. This video is sponsored by AWS and is part of my .NET on AWS series. Now without much delay, let's get straight into learning about converters and how to use them with DynamoDB. Now if you're completely new to DynamoDB and just getting started, I highly recommend checking out my Getting Started with DynamoDB video. It will be linked here and also in the descriptions below. Let's switch to Visual Studio where I have an ASP.NET API already connected with DynamoDB. This is something I walked through in my Getting Started video. Now this is the straight out of the code box of the ASP.NET template, which has the program.cs, the controller, which is the weather forecast, and also the weather forecast object. All I have done is to modify this object and add the property city name. So this city name is used as the partition key in our DynamoDB database. We also use the datetime as the sort key or the range key. Now in this particular controller, I have modified to remove the default code and it connects with DynamoDB and loads the data from DynamoDB. It already has two methods, which is the get and the post. We will be working with these methods to see how the custom converters can be applied to the types. Now the DynamoDB context is getting injected into the controller and it is set up in the program.cs. Here, using the builder.services, we have set up the dependency injection and injecting in the DynamoDB context. Let's switch over to my AWS console where I have the DynamoDB table already set up and it has some data inside that. So if I go under tables, weather forecast and explore the table items, I can see the existing items. Now let's open one of these items and you can see the content inside that. This matches exactly the same as the data that's there in our weather forecast class, except the temperature F because this is a calculated property. Now since summary in this case is optional, I had not populated when populating the data, so that is not shown inside this view. Now let's run this application to make sure it's all working as expected and let's start looking into converters. We have the Swagger UI open, so let's switch back to our DynamoDB. Let's copy this date and let's use the city name Brisbane and see if we can retrieve this data. So let's come back, let's try it out, let's specify Brisbane and let's paste in the date and let's say execute. Now this retrieves the data as expected and it returns the temperature 26. Now I'm able to connect to the AWS instance of DynamoDB because I have set up the credentials in the AWS toolkit to connect with my account. Now if you're not sure how to achieve this, I highly recommend checking out my video on AWS credentials, which will be linked here and in the descriptions below. Now with the initial setup out of the way, let's see if we add a new complex type property into this object, what happens. So let's go and add a new class. So let's say public class wind, which has the wind information for that particular day. So let's add the speed. So let's keep that as decimal. So let's say speed. And let's also add a property which says the direction of the wind. So let's keep that as a string. Now until now, all the properties of the weather forecast were native types. You can see there was string, datetime and integer. So in this case, let's add a new property which is going to be of type wind. So let's name this property as wind and let's run this application again. Now let's post a new item. So let's expand this. Let's say try it out. Let's give the city name as Brisbane. Now we have the wind object populated. So let's keep the date as 23/02/20, which is in UTC. So if you want, I can change this to my local time, which is 21 a day ahead. Now let's update the temperature. Let's say it's 20 degrees Celsius. Let's also update the wind speed and specify that's 4. And let's keep this as NE, which says northeast, and click execute. Now this is going to post us to the API and create a new item in our database. So if I was to copy this particular date and navigate back to DynamoDB, let's come back to the list of items. You can also sort these items based on the date property. So if you click that, the last added item comes on top. So let's navigate to Brisbane, and you can see here now we have the new wind property. It also has the summary, which is the string that we posted. So if we expand the wind property, you can see the two information that we send from the UI API. Now this is simply getting stored as a property and a JSON document. Now if we switch over to the JSON view, we can see the JSON object that's getting stored as the wind property. So for complex types that we use in .NET, it gets automatically converted as JSON and gets saved in the document. So if you add more complex properties inside our document, these gets automatically converted into JSON, and there is nothing specific that you need to do from your side. However, let's see if we add an enumeration type, what happens. So let's stop this. Let's collapse the sidebar and let's add a new enumeration type. So let's say we have a enum and we have the type as weather type. Now this is going to be none, sunny, let's keep it rainy, cloudy, windy, and let's also add stormy. So we have different weather types. Let's fix the spelling for this as an enumeration type. Now let's add a new property to our weather data. So let's say prop and then specify weather type and keep the property as weather type. Now this is going to be a new property inside our object. So let's run this and see what happens when we save a new item. So if you want to override the exactly same item, we can use the same key to be specified for the date. So let's copy that. Let's come back to the post and let's say try it out. Let's change the city name to Brisbane. Let's change the date to be that exact date that we want to override. Let's keep the temperature as the same. Now you can see the weather type in here is 0, which is the enum value for that particular enumeration. Now let's leave it as 1, which is going to be the first item in our list after the item none. That is going to be sunny. Now if I come back to DynamoDB database, let's refresh this. And you can see we already have a weather type and it has the value 1. So for enumeration types, by default, it gets converted into an integer and it gets stored in our database. We also saw that this is the same behavior that's happening in our API. So the enumeration value inside Swagger was getting shown as an integer. So it automatically converts it as an integer. Now to fix this, we can come back to Visual Studio. Let's stop this. And let's add an attribute on top of our weather type. So let's specify this to use the JSON converter and let's specify the type of and give JSON string enum converter. Now this converts the enumeration to a string value. So this is going to be sunny, rainy, cloudy, etc. as string values and it will automatically happen. So let's run this and see what happens in our API. Now if we expand the post and click try it out, we can give a string value for the weather type, even though the Swagger UI is showing this as an integer. So let's try that out. So let's say Brisbane. So let's leave that date to be the same and let's change the weather type to be rainy. Let's leave the wind direction and speed to be 10 and this as northeast and click execute. Now this has successfully posted this request to our API. So let's come back to our DynamoDB item and let's refresh this. Now the weather type has changed to 2, which is the value that is for rainy. So this is the second one in the enumeration. So DynamoDB is still storing this as an integer type, even though we posted it as a string type from our endpoint. This is because the DynamoDB does not look at the JSON attributes that is specified on the properties. Now to convert this and save this as a string value, we will need to use a converter. So let's see how we can do that so that we can start storing these weather type as string inside the DynamoDB. Now this is purely a choice you or your team may have. You could absolutely keep it as integers in your documents, or you could choose to change this to be string so that you can easily understand while looking at the document alone. Now if I come back to Visual Studio, let's stop this and let's add a new converter for this weather type. So let's create a new class. Let's call this as weather type DynamoDB converter. Now to make this as a converter for DynamoDB, we need to implement an interface. So let's add the interface IPropertyConverter, which is coming from the DynamoDB NuGet package. So let's implement that interface and add the two methods that it requires. So this has the FromEntry method and also the ToEntry method. Now the FromEntry converts the DynamoDB entry type, which is there in the database, and it converts to the dotnet class model that we want, which will be in this case weather type. And the other one takes in the object value, which is the dotnet type, and converts it into a DynamoDB entry. So let's implement these two functions for this particular converter. Now, when trying to convert from the DynamoDB value, we can directly use enum.parse and specify the type, which in this case is going to be weather type, and given the string value. So we can use the entry.asString method, which converts it as a string property. Now this simply passes the entry as a string and passes and converts it into the weather type instance. Now in the ToEntry method, we can do the opposite and convert the enumeration to be a string. So we can specify return new primitive, which is going to be the string, and we can pass in a string value for this. So let's specify value dot toString. That's going to convert it to the string value of the enumeration. Now let's put a breakpoint in here and in this FromEntry method. Now we need to specify the converter on the DynamoDB object. So let's come back to weather forecast, and on the property, just like we specified the JSON converter, let's also specify the DynamoDB property tag and specify the converter to use. So we can specify the converter equals and specify the type of the converter. In this case, this is going to be the weather type DynamoDB converter. Now let's run this and see how this behaves. Now let's expand the post. Let's say try it out. Let's update the city name to be Brisbane, and let's change the weather type to be cloudy. Now we can specify the wind direction to be 20 and the string to be NE, and let's click execute. Now in this case, this is hitting the ToEntry object and it gives the object value. Now that is cloudy. Now we are converting that value to the string value of DynamoDB and returning it. So let's continue this execution. Let's come back to our DynamoDB and let's refresh this. Now you can see the weather type is now stored as a string, which is cloudy. Now when I load back this specific item, so let's copy that particular date. Let's come back to Swagger. Let's say get method and try it out. Let's specify Brisbane and the date that is saved for it and execute. Now in this case, it's hitting the FromEntry method and it provides the DynamoDB entry value. So if I expand this, you can see the value is cloudy. So this converts it to an enum type and returns back to the DynamoDB converter values. Now if we expand this, you can see the weather type is also having the value cloudy. Now if I come back to the DynamoDB database and let's say I modify this to be windy and save these changes. Now the object is modified to have a different value. So now it's windy. So if I come back and load the same item, so let's go to the Swagger UI and click execute. Now this time the entry is going to be windy and it's going to return that particular enumeration type. So in the UI, we have the value as windy for the weather type. Now in this case, we specified the DynamoDB converter at the property level, which means if I add this property to another object, it's not going to get applied. So let's say, for example, the wind also had the weather type property. So let's add a new property here, which is the weather type. Let's keep it as the weather type inside the wind. Now before running this, let's make sure we also apply the JSON converter on this new property so that we can pass this as string from our API input. And let's run this to see how this behaves. Our API is launched, so let's click the post. Let's say try it out. Let's update the city name to be Brisbane. Let's add the temperature. Let's leave it as 20. Let's make the weather type as windy in both the cases. Now we have the property on both the wind class and also on the outside. So let's click execute. This hits the ToEntry object. So let's press F5, and it only hits once. So if I come back to our edit item in the DynamoDB and refresh this, you can see this weather type is now windy. Now if I expand the wind property, inside there the weather type is still stored as an integer. This is because the DynamoDB converter is not applied for that particular wind object. So if I go back to our Visual Studio, you can see only one of the properties have the weather type converter specified, which is at the root level. Now you can duplicate this at both these properties, just like we did the JSON converter attribute. If not, we can also specify this converter at the DynamoDB context level. So let's see how we can do that. So let's stop this execution. Now instead of specifying the converter at the property level, so let's remove this. Let's come to our program.cs and let's update our code here. Now to modify this, we need the instance of the DynamoDB context. So let's create a new context here. Let's create this as the new DynamoDB context, which requires to pass in a DynamoDB client, which we already have here. So let's pass that in. Now since we have the context here, let's use that to inject in the singleton instance. So just like before, where we injected the DynamoDB client, let's pass this explicitly inside this. Now once that we have the context access, let's use the context.converter cache and add the converter that we want. So let's specify add. Now this is going to be for the property weather type. So let's use type of and specify weather type, and let's also specify the converter. So this is going to be the new weather type DynamoDB converter instance. So now we are injecting in the converter at the DynamoDB context level. So anytime it comes across the weather type property, it will use this converter. Now this could be across different properties or even different tables in your DynamoDB context. Now similarly, we move this here. If we come back to the weather forecast, we can also move the JSON converter to the enum property. So let's put that on top of enumeration that we have defined. So we can remove that from all the places inside our properties. So let's also remove it from the wind. Now note that you cannot specify the DynamoDB property attribute on this class level. It has to be at the property type, which is why we define this at the context level. Now let's run this to see how this is working. So we have the method open. So let's add the Brisbane city. Now you can see Swagger has also started pulling up the appropriate string values for these weather type because we applied the JSON attribute at the class level. So let's make this as rainy, and let's also make this as windy to keep it separate, and click execute. Now it hits the ToEntry method, so you can see the value is rainy, which is getting passed as the first value, and then it hits it again, which is having the value as windy. So this method converter is getting hit twice because we have two weather type properties. Now let's continue the execution. If I come back to the DynamoDB database and refresh this, you can see that this property is windy, and if we expand the wind object, that is also now saved as a string. So both these properties are getting converted using the converter. Now when we read this back, so if I come back and use this datetime to read this object back, you can see the converter will get hit 2 times. So if I specify the city name as Brisbane and pass in the date and click execute, it hits the converters from entry with the value of rainy. And if I execute this, it will hit again with the value of windy. So it has hit 2 times the converter on the way saving the database item and also when we retrieve it. Let's see another example of the converter in case where we're using value objects inside .NET. Now if you are new to value objects, you can define custom value objects inside your .NET class. Now a value object is the case where the instances are equal because the value that it contains. For example, if you have 2 weather, which is 20 degrees Celsius, and if you have 2 instances of that, they are equal even if you create 2 instances of them with the same values of 20 and degrees Celsius. Now it's based on the value that it contains rather than the instance or the reference that it holds. Now if you want to learn more about value objects and how you can use them while programming, let me know in the comments and I'll do a follow-up video on that. But for now, I'm using a pattern defined in the Microsoft Docs which implements a value object. Now this has an example code that you can use as your base class for your value object. So let's copy this and let's come back to our application and create a new value object. So let's come back to Visual Studio. Let's create a new class. So let's call this as temperature value object. So let's paste the class that we just copied, which is an abstract class that has the value object. Now let's implement that on our temperature class. So let's specify value object. And in this case, we need to implement the abstract class. So all we need to specify is the properties that makes this temperature equal. So let's add two new properties into this. So let's specify this as decimal. Let's make this as degree. And we also need the temperature type. So let's add a new enumeration inside here. So let's specify as public enum temperature type. And let's give this as Celsius and also Fahrenheit. So we have two temperature types for now. So let's add a new property for that type as well. So we know that which temperature value this particular degree is in. So let's also specify this as temperature type. Now inside the value object, all I need to do is return these two properties. So let's specify yield return degree, and let's also return yield return temperature type. So it's saying that it's equal on these two properties. Now if you want to learn more about this implementation of value object, I will leave the link to this particular link in the descriptions below. So let's come back to our weather forecast class and add a new property temperature. Let's leave the int property right there without affected. So we have the property that's added, which is temperature, and that is getting saved inside here. Now let's run this to see what is happening in this particular case. Now we have the Swagger UI opened, so let's expand this. Now inside the JSON representation, we can see there is a temperature and it has the degree and the temperature type. Now let's add it a value. So let's give this a value. Let's make this for Brisbane. Let's give the temperature as 20 and let's leave the type as Celsius, which is 0 in this case. And let's click execute. Now it hits the converter for the weather type. So let's remove these breakpoints because we are not interested in this anymore. Now once that is saved, let's come back to our object inside DynamoDB and let's refresh this. Now we have the new object inside here, which is the temperature. Now if we expand that, you can see this is getting saved as expected. So it has two properties, 20 and the temperature type as 0. Now you know how to add a converter for this temperature type, which we saw earlier for the weather type. Now what if we want to save the temperature as a single field, let's say as 20 degrees Celsius instead of these two properties. So let's add a converter for that. So let's come back to our Visual Studio. Let's stop this and let's add a new converter. So let's create a new class, which is going to be temperature DynamoDB converter. So as before, let's implement the interface, which is going to be IPropertyConverter. And let's make sure to implement this to add the two methods, FromEntry and the ToEntry method. So first, let's do the ToEntry method. So let's check if this particular value is of temperature type. So let's say value is temperature. Let's capture that as a temperature object. And then let's convert this into a single string. So let's specify the unit that we want to use. So if the type temperature has the temperature type as Celsius, so let's say that is temperature type dot Celsius, then we can convert this as C. If not, let's leave this as F. You can do advanced pattern matching to case for different temperature types that you might have in your application. Now once we have the unit, let's use that to convert the primitive that we created earlier, because we're going to save it as a string. So let's use string interpolation here. So let's use $, and let's specify the temperature dot the degree. Let's also specify the degree symbol, and let's specify the unit that it is in. That is again to be string interpolated. So let's specify unit inside the brackets. Now I copied this symbol from Google, but you can also use other ways to insert this. Now once this is converted, this is going to return this as a DynamoDB entry. In the other cases, if it's not a temperature, let's simply return null. Just make sure that this DynamoDB converter is only applied to the correct property types. For other cases, it just returns null. Now, in the FromEntry method, we need to reverse convert this particular string representation into a temperature object. So let's first make sure that the entry is not null. So let's say entry not equal to null. And if that is the case, we can return null in this case. Now, if the entry is not null, let's capture first as the temperature string. So let's convert this entry because that is going to be as a string inside the DynamoDB. Now, once we have the string, let's split this based on the degree symbol and convert it into the temperature object. So let's say where temp strings is equal to, let's split this based on the degree symbol. So let's again paste that symbol in here and let's specify string split options as none, or remove empty entries so that we don't have any empty entries. Now, once we split this, we can use the first value to be the temperature value and the second one to determine the temperature type. So let's get the value unit. Now we can say temp strings and the first index. So let's specify bracket 1 and let's specify the switch on that. Now, if this is going to be C, then we are going to return the temperature type as C, which is Celsius. Now, if this is going to be F, then we are going to simply return this as a temperature type and specify this as Fahrenheit. For anything else, in case we don't know, we can throw an exception or use temperature type none as an option inside our enumeration. For now, let's simply throw an exception. So let's say I throw a new exception and let's add the message invalid temperature type. Now, once we have the unit, we can use that to create the object. Now, since we have the entry, so let's convert this. So let's return a new temperature object. So let's specify temperature. Let's specify the temperature degree value. So let's simply use decimal.parse and then also pass the unit that we just created. Now we can also create a new constructor for this temperature class. So let's make sure we always have the degree and the temperature type specified. So if I come here, let's add in both these properties and assign it as automatically Visual Studio suggests. So we have the temperature constructor defined and we also have this object created. Now, before we apply this converter onto the property, let's see how DynamoDB behaves with this new constructor in this class. Now, since this does not have a parameterless constructor, DynamoDB will not be able to create an instance of this. So let's click F5 to see that first. So once we have this running, so let's expand the weather forecast. Let's say try it out. Let's use this for Brisbane. Let's keep the same date. Now let's change the degree to be 20 and let's keep the temperature type to be Celsius itself and click execute. Now if we scroll down, this returns an error which says temperature is unsupported, it cannot be instantiated. Now this is because we don't have a default constructor on the temperature class. Now this might also be a scenario where you'll have to have a custom converter so that you can specify how to convert this type to a DynamoDB type, just like what we have done now. Now let's go and apply that converter and see how we can fix that. So let's come back to the program.cs. Let's create a new converter cache. So let's specify context.convertercache.add. Let's add the specific type. So in this case, this is going to be temperature. And let's create a new instance of the temperature DynamoDB converter. Now once that is set, let's run this again. And let's pass in the same values for our temperature object. So let's expand this, try out. Let's specify this as Brisbane. And let's also specify the degree as 20 and leave the type as Celsius. Now in this case, when I execute, this gets saved successfully. Now if I come back to DynamoDB and let's refresh this, and you can now see that the temperature property is saved as a single string. So in this case, it is just saved as 20 degrees Celsius. Now if I return back this object, so let's say I copy this particular date, let's come back into the get, try it out, let's specify Brisbane, and let's specify the date and execute. Now if you look at this, it converts this back into the temperature object. So if we were to put a breakpoint inside our new converter, so let's come to the from entry and also in the to entry, and let's click this get again. Now in this case, you can see the entry is 20 degrees Celsius, so it's not null, which means it converts this to a string, which is a temp string, and then it splits that on the degree symbol. So we get two of these values, which is 20 and C, and then we convert it based on the C to the unit and use the decimal to parse it as a decimal and return the temperature. Now in the case where we are saving this, so let's click the execute on the post again. In this case, this is coming in as a temperature value, which is 20 Celsius. So it just converts that as a string directly here. Now if I was to come back into DynamoDB and let's change this to be 20 degree Fahrenheit and let's save the changes. And if I come back and refresh the get, this is going to return this object as 20 Fahrenheit. So let's continue the execution. And let's look at the response, and this has now temperature type as 1. Now if you want the temperature type to be a string inside this, we can apply the JSON converter on that enum as well. So let's stop this execution. Let's come back to temperature and let's specify the JSON converter in here. So let's specify JSON converter and let's specify the type, which is going to be the JSON string enum converter. So let's run this again. And from now on, you can see this is going to be converted as Celsius or Fahrenheit based on the value we choose inside the API payload as well. I hope this helps you to understand about converters and how that gets used in DynamoDB. Now when you're using custom types based on your programming languages, you can use converters to save them differently inside the DynamoDB database. We saw how to store enums as string when using enum as a property on your document, and we also learned how you can convert complex types into a single string representation. We used this in the temperature class and we converted the two values in that, which was the degree Celsius or Fahrenheit, and put it as a single value in our DynamoDB table. So we saw how the property converter has the to and the from methods and how that's getting used inside the whole conversion process. If you like this video, please make sure to hit the like button. If you want to be notified of future such videos, make sure to hit the subscribe button. It also helps me to grow this YouTube channel. Thank you and see you soon.